Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabazz Dan, and as ever, I am the IT Geek. Welcome back to another AZ700 Designing and Implementing Microsoft Azure Network Solution series. So this is exam prep, kind of an exam prep series to help people who are preparing for the AZ700 exam. We started module 3 in the last episode, so this is part 2 of the Designing and Implementing an Azure Load Balancer topic. As normal, there'll be me doing the theory, and that'll be followed by my good friend Mohammed Sajid doing the lab. So let's get started with this episode. So as I mentioned, we are deep, well not deep really, we just touched the surface of designing and implementing core application delivery services, which is module 3. Today is part 2 of the designing and implementing Azure Load Balancer topic, and we're going to talk about first creating and configuring an Azure Load Balancer. Then we're going to talk about creating and configuring inbound NAT rules, followed by creating and configuring explicit outbound rules. And finally, pass the hand over to Saj to do the demo on implementing a load balancer rule. So let's talk about creating and configuring an Azure load balancer first of all. So you need to have, you need to create a virtual network. So without the virtual or a VNet, you can't configure a load balancer. That's a kind of a prerequisite. The kind of steps that you take when creating a load balancer is, first of all, you need to create the front-end IP address, which is sort of for the private resources. Then that back-end pool. For front-end IP addresses for depending on what type of load balancer you're going for. Could be public or could be private. Then you go for back-end pool. And then those inbound load balancing rules. And then you configure a health probe, and we discussed what's quite a few of these capabilities and features were in the last episode. So let's move on to the topic of creating and configuring inbound NAT rules. So an inbound NAT rule is used to forward traffic from a load balancer front end to one or more instances in that back end pool. And there are really two types of inbound NAT rules. The first is a single virtual machine, which is an inbound NAT rule that targets a single machine in that back-end pool of the load balancer. We then have a multiple virtual machine NAT rule. And as the name suggests, this is an inbound NAT rule that targets multiple virtual machines in that back-end pool of the load balancer. Some prerequisites: you need to have a standard public load balancer first of all. And you can also use the Azure Portal Cloud Shell or PowerShell to kind of configure the inbound NAT rules. Just wanted to touch on creating and configuring explicit outbound rules before I hand over to Mohammed Sajid for the lab. So outbound rules allow you to explicitly define source network address translation, which is SNAT, for a public standard load balancer. This configuration allows you to use public IPs for your load balancer to provide outbound internet connectivity for your load backend instances. So this configuration enables IP masquerading, which essentially means you essentially hide your private IP address. It simplifies the allow list. Also reduces the number of public IP resources for deployment as well, because again, you can masquerade, or you can point or redirect multiple instances on the back end to one public IP address. With outbound rules, you can explicitly define outbound SNAT behavior. So I just want to stick on this topic of creating and configuring explicit outbound rules before handing over to Mohammed Sajid. So outbound rules allow you to control which virtual machines are translated to which public IP address. So say that you have two rules where the backend pool uses both IP addresses, and another backend pool uses another IP prefix. Also lets you control how outbound SNAT ports are allocated. So if a backend pool is the only pool making outbound connections, you give all the SNAT ports to that backend pool and none to any other backend pool because they're not making any outbound connection. You can also control which protocols to provide outbound translation for. So if a backend pool needs UDP ports for outbound, but another backend pool needs TCP, give TCP ports to one and UDP ports to the other, for what they require. You can control what duration to use for outbound connection idle timeout as well. So the choice is 4 to 120 minutes. If there are long running connections, we've sort of keep alive reserved idle ports for long running connections for up to say 120 minutes. You can control that. And assume stale connections are abandoned and released ports within 4 minutes for fresh connections. The final thing you can control is whether to send TCP reset on idle timeout. So when timing out idle connections, do we send a TCP RST to the client and server so they know that the flow is abandoned, or don't we? So something else you can control there for those explicit outbound rules. So a bit of a shorter episode from me, a bit short theory. So again, just want to try and focus on some of the practical element. So I'll be handing over to Saj now to do a demo on implementing a load balancing rule. Over to you, Saj.
Thank you, Shabazz. So Shabazz just gone over load balancers. We're going to take a look at creating load balancing rules. To create load balancing rule, you need to create a load balancer, which I've already pre-deployed here. So to create a load balancing rule, go to your load balancer, and under settings, you've got load balancing rules. Now, to be able to demo this, I'm just going to quickly step through the lab. So what we have is a backend pool with 2 VMs in it, AZ700 demo 01 and demo 02, with an IP address of 10.1.0.5.5 and .7. We've got front-end IP configuration for the load balancer, which is 10.1.0.6. They're all on the same network. We have a client machine, which is this one, which is on a completely different VNet and a different network. And if you've been following this series through, if you review the series on creating a virtual WAN and how to create hubs, it will show you how this communication works. So we've created some virtual hubs, and it creates some connectivity between the 2 VNets that allows this connectivity to happen. So if we connect, for example, to our client machine, which is demo host AZ700 demo 02, and we ping the hosts that are running IIS 10.1.0.5, you should be able to communicate from a machine that's in a different network. It's pretty slow today. So, and 7, we should be able to ping 7 as well. So that works fine. Just IP config on this machine. Let's check its config. So this is in a 10.2 network, and because of the virtual WAN and the hubs that we've created, it can communicate with a machines running a different environment on a different VNet 10.1.0.5 and 10.1.0.7 in a 10.1.0 subnet. So back to the demo quickly. So if we navigate back to our load balancer and we go to AZ700 load balancer, we look at the front-end IP configuration again, just to remind ourselves. It's an IP address of 10.1.0.6. Backend, we've got a backend pool with 2 VMs in it with an IP address of .5 and .7. And we've created 2 rules, port 80 rule and a port 443 rule. To create a rule, select add, give it a name. So load balancer rule 01 as an example. IPv4, IPv6, front-end IP address. So give it an IP address. So this is an internal load balancer. You can also do this for external load balancers, but I'm doing a demo for the internal load balancer. AZ700 with an IP address of 10.1.0.6. Might come up with an error because it's already in use. Backend pool, again, we'll select the existing backend pool. Enables load balancing on all ports for TCP and UDP. So when we leave that as default, we don't need it TCP or UDP. So we can leave it as default for this example. Both of them existing rules have been created as TCP. So we've got port. So this is front end port is coming in. So it can come in on one port and actually communicate to the back end with a different port. But the rules I've created, so you can go, for example, 80 and then go 443, or go 443 and the back end you want as 80 as an example. But the rules that I've created are 443 to 443 and 80 to 80. So you can leave that as 443. Health probe. So I've created 2 new health probes. If you don't have health probes, you can create a new health probe here. Give it a name. Health probe 01 as an example. Protocol. So it'll look at TCP, HTTP, or HTTPS. So HTTP as an example. Port 80, port 443, port 25, whichever port, and the path and the interval. And it'll create you a new health probe. So we're going to leave that as it is. We can use an existing health probe in this demo, so 443, so we've got 443 health probe there. Session persistence, so this is about session affinity. So if you read the information, it says session persistence specifies that traffic from a client should be handled by the same virtual machine in the back end. So traffic coming in will be handled by the same virtual machine in your backend pool. In your backend pool, you can have 1, 10, 20 machines, depending on how you've configured it. Idle timer, default is 4. Keep TCP or HTTP connection without relying on the client to send a keep alive, 4 seconds. You can configure this up to 30 seconds, I believe. As a maximum, leave it as a default. You've got TCP reset, floating IP, we leave as default. So click add and create your rule. So just review the ones that we already created. AZ700 demo load balancer rule 01 18443. Same process, IPv4, front end IP address, the backend pool, TCP, port 80 coming in, port 80 at the backend, the health port for port 80, and no session persistence. And again, the same for 443. Now to demo this, if you take the IP address of the front end IP address of your load balancer, again, remember this is a demo for the internal load balancer. Go to our client machine. Hopefully it'll work, because load balances not necessarily round robin. Sometimes they'll give you the same one continuously. So here we've got 10.1.0.6 and it's looking at demo 2. On the edge, we've got 10.1.0.6 and it's looking at demo 01. So it load balance between the two. But if we just try another one and see what happens, if we get lucky, so it's going to demo 02, and then it's connecting to demo 01 and load balancing between the two virtual machines. Thank you for watching. Back to you, Shabazz.
Thank you, Sarge. Another very, very informative demo, and again, a good way to finish off this topic. I hope these obviously episodes are informative. Please do drop me a comment. Let me know if there's anything you feel I could go into more detail about. If there's anything you feel I missed. And obviously, do give us a like, and don't forget to subscribe. Like I said, just broken that 1K barrier. I want to keep on growing the channel. I'm really, really enjoying doing the content. You probably noticed I'm doing more content, different topics. So I'm really enjoying doing it at the moment. So please, do keep on supporting me. Smash that subscribe button. So thank you very much for watching. The next topic we're going to be covering, again, is another two-part episode. And it'll be around Azure Application Gateway. So thank you for watching, and until next time, goodbye.